The purpose of this design bulletin is to provide guidance for the use of the Utility Conflict Matrix, or UCM. The UCM is for the identification of utility conflicts with new roadway design features. UCMs are designed to help CDOT and utility companies identify the best and most cost-effective solutions. The UCM is designed to be scalable and support a range of project sizes and conditions in varying levels of project design. The immediate benefits of the UCM process include proactive identification of both utility conflicts and alternative design solutions to minimize costs and foster greater communication among affected parties. Together, these improvements lead to more cost-effective processes with reduced risks. Ultimately, the benefits of using a UCM on a roadway and bridge construction project includes fewer contractor change orders and delay claims, reduced costs from construction delays, improved project development procedures based on anticipating and resolving utility conflicts early in the process, better communication among transportation agencies and utilities, reduced impacts on the public from construction-related delays, reduced impacts on the public from utility disruptions, and improved worker and public safety from construction-related hazards. The UCM can be found in PDF format. Also, there's a microstation DGN file and the embedded utility matrix template in Excel format in a spreadsheet. Can be found at the utility program website, also at the following Google Drive link. Utility engineering at CDOT includes the following phases: planning phase 0 to 30, 30 to 90, 90 to 100, and then construction phase. Within those phases, you'll see at the top left in red, from planning phase through about 90% design, we're conducting SUE investigation, gathering existing utility information, and test holes. On the bottom, you'll see the blue utility coordination, which begins at planning phase and works all the way through to the construction phase. Upper right in green is the construction management phase, beginning at about 90%. With early relocations and running to the end of construction. So the green in the middle is really the focus on the utility conflict matrix and where it's used at around 30% design. So when you look at subsurface utility engineering investigations, quality level B, trying to obtain that data by 10% design, and then allowing designers the time to leverage that SUE information up to 30% design, that will then shape the utility conflict matrix much better because you've had the ability to design and have time to design with quality level B information or SUE information, or even just good existing utility data in order to build that utility conflict matrix. While leveraging quality level B information and the current 30% design on the utility base map, you'll see the existing utilities called out on this particular map with the appropriate quality level assigned to it. But then when you start looking at the proposed storm drain improvements overlaid, there's a lot of potential conflicts that arise on this particular project. In red, you'll see the electrical conflicts, in yellow, the gas, blue, water, etc. And so at this point, we're determining, is there an opportunity to avoid any of these relocations? For instance, maybe a high pressure gas line relocation, or maybe a major fiber and duct conduit run of some sort that leads to an airport or 911 dispatch center. So at this point, we're really trying to identify where test holes are appropriate, where design modifications can be made. But again, once all this data is captured, it will be shown in the utility conflict matrix. So building off the last slide where we had plan view, potential conflicts, and test hole identification, now we've actually gone out and completed the test holes, and we've captured all the appropriate information in our utility conflict matrix. The template that we have provided for the utility conflict matrix includes all of the same fields that you see on this example. So again, you have the utility owner, you have the conflict location, you have test hole data, conflict data, and then conflict resolution, and then those subheaders underneath that. And so the goal of our matrix is to identify survey information on the utility and what the elevation conflict is, and then the description and a resolution, and then when will this estimated resolution date transpire. So is it during construction? Is it early relocation, by FOR, by 90%, etc. So again, from 10 to 30% design, we're looking at the SUE information being delivered, and then allowing designers to leverage it from 10 to 30% to, one, look at avoiding utility relocations altogether if possible, or two, how the utility conflict matrix could show that we could accommodate those utilities, maybe an adjustment in place or modification to our design in some way to allow for that utility to stay in place, and maybe it's something that will keep the project out of a long, lengthy utility negotiation and relocation project. But if it cannot be avoided or accommodated, then relocation will have to commence at some point, and the utility conflict matrix will capture that relocation effort, who's responsible for it, when it's going to happen, and allow better negotiations with the utility companies. Now that you have a fully assembled utility conflict matrix, sit down with the stakeholders and work through any outstanding items related to the conflict matrix. For example, if you have unknown utility elevation information, or it looks a little suspect, then work with your SUE consultant to resolve any of that information in your matrix at this point. Also, sitting down with the utility providers to resolve any final touches on the schedule, recommendations, and action and resolution areas of the utility conflict matrix is extremely important at this point. And then relaying all that back to internal staff, CDOT staff, including designers, project managers, resident engineers, program engineers, from the design and budget perspective and scheduling of these utility relocations is extremely important. And then if utility relocations are eligible, they're in easements, and the relocations are the responsibility of CDOT, then it's important to move contracts like ICCs or SUAs forward in that process around 60 to 90%, so that those can be completed prior to any early relocations that are maybe to happen around 90%. CDOT design is extremely important. And then finally, the use of the utility conflict matrix and this process will help finalize the specifications, the utility specifications at the FOR level, and then prepare those for PS&E. In summary, gather SUE information early in the design phase. This will allow the identification of potential utility conflicts as you approach 30% design. Post 30% design will allow for test hole investigations that will in turn prepare the utility conflict matrix. The utility conflict matrix will allow both utility and project level designers to evaluate alternatives. Also, the matrix will allow for utility impact analysis on schedule and construction phasing. The matrix can also be leveraged for coordinating with stakeholders about their pending relocations. As you can see, this is an iterative process, the back and forth between CDOT designers and utility companies and their design team to come up with the best solution for everybody, with the goal in mind to minimize any unnecessary utility relocations.